Okay, so a two-way table displays the same information as a Venn diagram. Ooh, don't you love a Venn diagram? And now our Venn diagrams, these would be mathematical Venn diagrams where we would put in like numbers, like we would count things. Okay, so we would have numbers. I know sometimes in English you might just have like statements about stuff. Okay. In the table, one category will be represented by the rows. So that would be like in the Venn diagram, one of the circles. Okay. And the other category, the other circle, is going to be represented by the columns. And, you know, like in a Venn diagram, a lot of time your two circles have some kind of intersection, right, where they overlap. So that's going to be included in, like, when the rows and the columns intersect. Okay. If you look back to the warm-up that we just did on the back of the finding or the rolling dice activity, that was a two-way table. I think the columns were your age group, right? And your rows were your level of education. So it was grouping them individually. Okay. Down at the bottom of or at the top of this page, sorry for you guys, we have a Venn diagram regarding a survey of 80 students and whether they play an instrument or speak a foreign language, and you can see some overlap. Okay, and then the whole sample space is the rectangle. Can you guys as a group work together to take the information from the Venn diagram, the numbers, because we're doing math, take the numbers from the Venn diagram and place them into a two-way table where category 1 is whether or not I play the instrument, that's the title for my columns, and category 2 would be like whether or not I speak a foreign language, that's my rows. So see if you can take the information from the Venn diagram, put it in the table, and then use it to answer the questions in the boxes. So you don't really need me for this. Go ahead and work on it. I'll put my answers up in a little bit. And if I notice something I disagree with, I'll tell you. Once you get the table filled in on the right, you start answering the questions in the boxes below. Maybe check them with your group. Make sure you agree on numbers. So far, I haven't found any I disagree with. As I walked around, I tried to check your two-way table, and I haven't found any that I disagree with. And I haven't mentioned, I've tried to say something to you, but it is worth your while because I'm looking at a lot of papers there just to double check your numbers. Make sure you agree with those on the screen. And then make sure you're working on answering those questions, follow-up questions in the boxes. Either way is fine. I'm going to write a fraction or the setup and the decimal. Okay, so you can take a moment to look up on the screen and see if you agree with my numbers that I've pulled out. If you leave your answers as fractions, that's fine. Just remember that as final answers on quizzes and tests, always in math, your answer should be simplified. So if you were doing like the second problem over on the right side that said 46 over 80, each of those is reducible by 2. So then you would write 23 over 40 as your final answer. Okay. If you want to avoid that whole issue of simplifying fractions, then you can just type it into your calculator and write the decimal answer. If you round it to the nearest like hundredth or something, that would be okay. So if you have like 0.31 instead of 0.3125, that's okay. All of those were terminating, so I had no issue writing them. Okay. Are we okay with this so far? Okay, so like it's just kind of like the warm-up. Like you actually know a lot about two-way tables and how to work with a two-way table without me telling you about it. In a minute here, we're going to fill in the vocab because as you progress in math, we have an AP Statistics course here, and we also have a one-semester Prob and Stats course that's not AP. But as you progress and you're taking like statistic courses, you're going to be seeing more vocabulary like you see at the bottom of the page. So we kind of want to introduce that to you now. One thing I want to point out about this chart is the differences between the left and the right. So notice on the left, I was just pulling this from my two-way table. And this is like the number of students that do these things, right? So all of these numbers are what I refer to as frequencies. And you might also think about like our rolling dice activity yesterday, like with what frequency did you roll, a sum of 3 or a sum of 7? You can also think about these like these are almost like tallies, right? I'm just counting how many times something occurred. Okay. So on the right, those become the numbers that you might use as your favorable outcomes for a probability. So all of these problems on the right are asking questions of probability. Remember, when you do a probability, that those come out looking like ratios. Okay, so a ratio in math you know, when you first started doing ratios, you would do that ratio with the colon, 2:3, 2:3. Okay. But eventually we graduated and we said, well, a ratio is really just a comparison of two values. Let's write it as a fraction, right? So we can also think about the basic probability formula, favorable over total. It's really the ratio of favorable outcomes to total outcomes possible. And how do they relate? So probabilities are always ratios. So then we got this vocab stuff down at the bottom. Oops, sorry. Okay, I think the first one is still a fill in the blank. A frequency table that displays data from one source that belongs to two different categories. And on quizzes and tests, usually if anybody has trouble with the frequency or with the two-way table, it's because when they're reading the problem, they can't decide what the two different categories are. So if you're really feeling stuck in setting up a table, try to really narrow it down to like what are the categories. So like in that warm-up problem, the top category was age range, the side category for rows was education level. In the two-way table that you just created, we have a category for instruments, and we have a category for foreign language. And that's just a simple like yes or no, you don't do it. Okay? So try to figure out what the two categories are. A lot of times you're going to see categories, you know, that might split us up, you know, gender, male and female, and then whatever we're working with, or age groups is a very common one, so that we're kind of like separating data in those ways. Okay, joint frequency is a single entry in the two-way table. A single entry in the table is a joint frequency. And it's called a joint frequency because it's joint with a column and a row, right? Like it's the age range and that specific education level, and that one entry is those people who meet those two qualifications. So those are joint frequencies. Okay. Marginal frequencies, where are margins? On the sides, on the outside, right? If you're a marginalized group in society, you're on the outside of the norm, okay? So you feel marginalized. So margins are on the sides. These are the sums of rows and columns. So it'd be like in that warm-up example where we had the column of 25 to 34-year-olds, and then we had all the different education levels. When we just add up all the different education levels, we don't have joint frequencies anymore. We have a marginal frequency. It's the frequency of how many people in that survey were 25 to or 24 to 34 years old, whatever that was. Okay, so that's the sums of rows and columns. So before I get into the relative frequencies, I just want to go back to that two-way table that you guys have already filled out and kind of highlight what's what. So in this particular table, your joint frequencies are the frequencies where you're bringing together a row and a column from the two categories. So 16, 30, 25, and 9, these are joint frequencies. The numbers, when you sum the rows or sum the columns, when they're in these total columns, those aren't joint because they're not bringing together the two different categories. These numbers right here are your marginal frequencies. So how often we do speak a foreign language, or how often we don't play an instrument, whether or not we speak a foreign language. Okay, so they're counting the totals. Okay, so those are on the outsides. Now, notice that the next two words, and this is where it gets difficult when you're taking like a prob stats class. Notice that the next two words are almost exactly alike, except they have the word relative, right? So what's a joint relative frequency and a marginal relative frequency related to joint frequencies and marginal frequencies? What the heck? Okay. Well, the key word here is relative. Think about your relatives. They're your relations, right? And in math, when we're talking about a relation or a relationship, we're talking about a comparison, a ratio. So these things, relative frequencies and marginal relative frequencies, those are going to be ratios, so they're going to be fractions. They're going to look like probabilities. So the word relative is also synonymous here with ratio. So for a joint relative frequency, I would say it's the ratio of a joint frequency to total outcomes. Oops, can't spell. Essentially, what I'm describing right there is a probability. The favorable outcome is the joint frequency, and then we've got the total outcomes in the two-way table. The marginal relative frequency will be the ratio of a marginal frequency to the total outcomes possible. Okay, got rid of all this stuff because I didn't like it. So this one will be the ratio of a marginal frequency to total outcomes. And again, because it's a ratio, it's a probability. Remember what I wrote on those, like these are frequencies and these are probabilities. These are ratios over here. Okay, so it's a fraction. It's a comparison of two values. But each of those, joint relative and marginal relative, they're relative to the whole table. So you're looking for like your total number of people. In the example with the foreign language and the play and instrument, it's that 80 people. Okay, so you're dividing either a joint entry by or joint frequency by 80 or a marginal frequency by 80. Okay. The last one is conditional relative frequency. And of course, this is like what we talked about with independent and dependent events. This is, of course, another ratio because it's relative. So it's the ratio of a joint frequency to a marginal frequency. It's like that given probability. If I know the person plays an instrument, then what's the probability that they also speak a foreign language? So I'm taking that joint frequency, plays an instrument over and speaks a foreign language, and I'm dividing it only by plays an instrument if I know they play an instrument. Okay, so on the back side, we've got some examples. Okay. I think the key here is like maybe these vocab words are going to be important in terms of directions, what you're going to be asked to do. But you guys by yourselves are going to feel really confident with tables. So read through the first example, the survey of students, and create, it says, organize the results in a two-way table. So you decide the two different categories and you make your table. This is number one. It doesn't have a one. It has a bullet point. I'm sorry. So create a table. Sleep at the top. What are your two different categories? I would say this is the most popular looking table I see around the room. One row or column group is going to be boys or girls. The other is going to be for or against, right? Whether you voted yes or no. So those are your two categories. Gender, vote. Now I just have to fill in what I know. So I randomly survey students about whether they are in favor of planting a community garden. Of the 96 boys, that's a marginal frequency. All the boys add up to 96. 61 are in favor. Using mathematics, I know that leaves me with, 35 against our community garden. Of the 88 girls surveyed, that's another marginal. This is all the girls. 17 are against. Which mathematically that leaves me with 71 for. And it says organize the results in a two-way table. I think we've got that. Then find and interpret the marginal frequencies. So my marginal frequencies, recall, are the ones where it's the total sums for the rows and columns. So I've got my 96 and my 80, but I'd also like to have marginal frequencies for my votes, for and against. So I'll add across, what do I get? 132 and 52. So that's a total of 184. But if I'm interpreting the marginal frequencies, I'm saying something about the numbers 96, 88, 132, and 52. And really here, it's almost like you're a reporter. You did this survey. Report back what things you learned. Okay? So I would say this for my interpretation. 96 boys and 88 girls were surveyed. I've just reported about the marginal frequencies for my gender groups, boys and girls. Then I should report on the marginal frequency for my voting groups, for and against. 132 respondents, or people, whatever you want to call them, voted for the garden. And 52 voted against. So we've just summarized what we learned in that voting piece. You know, later on, if you're in a stats class, you might look at that in terms of what does that mean? We might feel good that we had equal number of boys and girls being surveyed, and we wouldn't want to only ask girls and not ask any of the boys. Okay, we can see that the results are going to say we should build our community garden because we have more votes for than against. Okay, so it's just summarizing what you see in the table. Okay, questions? Okay, try filling in number 2. Okay, it says complete the two-way table on the left. So fill in the blanks. So you're doing a little bit of math. That part I think is fun. And then we're going to use the two-way table to create another two-way table that shows the joint relative and marginal relative frequencies. Okay, doing my little bits of math. I know I have 130 people that are being surveyed on their transportation method and whether they arrive on time or late. So I know 60 people take the city bus. That must mean 70 people are walking. So that it adds up to 130. And then 58 people were on time, so that leaves me with, 72 people who were late. And then I can kind of fill in the rest of what I know. So this obviously has to be 50 people take the city bus. Then I have 10 people who took the city bus and were on time. And then it must be 48 people right here. And I can like double check, like it should be true in all rows and columns, right? Okay, so sometimes your two-way tables on your homework are going to look like this, where they have frequencies in them, tallies, just the number of people who fit those categories. Other times in your homework, you might get a table that shows joint relative and marginal relative frequencies, and relative means ratio. Ratio is probability, it's division, it's a comparison of two values. So what you're going to do for this table is you're just going to take each of these entries, joint entries and marginal entries, and you're going to divide by 130. Yep. So you're putting in the relative frequency, that should be a probability. Now you can decide if you want to do a fraction or a decimal. So for this first entry right here, I'm going to do 22 divided by 130, and that is 0.17. I'm going to go to the nearest hundredth. 48 divided by 130 is 0.37. And I could either add those up, or I could do 70 divided by 130, should be 0.54 either way. So if you're asked about a two-way table of relative frequencies, then you actually want the probabilities in the table. But the rule should still remain the same when you do these relative frequencies. The joint frequencies should add up to be the marginal frequencies in the rows and the columns. That one in the second row, third column says 0.46. So it looks a little funny. Okay, you guys feel okay with that? Okay, so I just want you to be aware, like, depending on what the problem looks like or asks for in the homework, make sure you're either doing frequencies, which are tallies, or you're doing relative frequencies, which are really ratios. There should be decimals, they should be probabilities, so they should be between 0 and 1. Okay. We won't have time to get to that third example, but there's an example similar to it in the textbook, so if you have any homeworks like that, you can look back at that example in the section. Or we can talk about it tomorrow when we go over our homework. If there's like maybe part C would be the tough one when you determine if they're independent or not. So you have a homework assignment. It's in the textbook. It's on your gold sheet. It's also at the bottom of your notes. Okay. Oh wait, it's 12:39 today, isn't it? What do you want to do? Have 9 minutes to work on your homework? Prefer that? Yeah, I'm okay with that. I always put a little extra example on probabilities. I'm not always necessarily dying to get through every one, so I'm okay with that. Let's work on our homework, and then you can ask questions if you have them.